Welcome to Ask and Learn.
So to determine this problem, we see that in discrete math, it's really helpful to know the different kinds of combinations, the different possibilities. That'll become extremely useful in probability, combinatorics, a lot of these types of math applications. And we want to know how many possible ways there are to have DNA sequences that end with A. So the cases for that would be first, if it's going to end with A and it's going to be 5 sequences, we could have it start with A, it could start with G, it could start with C, or it could start with T. It doesn't matter what it starts with. So we know that the first base has 4 possibilities. Similarly, the second base has 4 possibilities. The third base has 4 possibilities. The fourth base has 4 possibilities. And then we know that there's only one possibility for the fifth base because it has to be A. So based on that, we see that there are 256 different possibilities of those DNA sequences. Next, we want it to start with a T and end with a G. So we know there's only one possibility with what it starts with. There's 4 possibilities for the third base, 4 possibilities for the fourth base, and only one possibility for the fifth base. Therefore, based on the product rule, we know that there are only 64 possible DNA sequences in which that's the case. Then we want it to contain only a T. So that means for the first base, there's 2 possibilities. Second base, there's 2 possibilities. Third base, there's 2 possibilities. Fourth base, there's 2 possibilities. And fifth base, there's 2 possibilities. This is the same thing as 2 to the fifth, which is going to be 32. So that means if the sequence just contains A or T, that means we would have 32 possible combinations. Then we want to do it so it does not contain C. So if it doesn't contain C, this is fairly simple. We know that it can contain A, G, or T. So there's 3 possibilities in all 5 cases. So we could do 3 times 3 times 3 and so on. Or we could just recognize that this is going to be 3 to the fifth and see that if we don't include T, then there are 243 different possible DNA sequence combinations.